Hi, my name is Jarhoz Ahmed, and in this video we'll discuss about the waves. So let's start off with the definition first. So waves, it is basically a medium that transfers energy from one point to another. So I'll write it here. It is a medium by which energy is transferred from one point to another. Energy is transferred from one point to another. So this is basically a wave. Now we have two types of waves. Number one is the transverse wave, and the other one that we have is the longitudinal wave. So the difference between the transverse waves and the longitudinal waves is that in the transverse wave we have so basically the waves are produced by some vibration or by some disturbance in a medium. So when we disturb some medium, a wave is produced. So the transverse waves are produced if the vibration is perpendicular to the direction of the wave. For example, if the wave is going in this direction and we are vibrating the medium in the perpendicular direction, like up and down, the wave is going towards right and the vibration is up and down. So this type of wave is called a transverse wave. And the longitudinal wave, let's suppose the wave is going in the direction towards right and we are vibrating the medium like this, right left. So where the transverse waves are produced when the vibration is perpendicular to the direction of the wave, and longitudinal waves are produced when the vibration is parallel to the direction of the wave. So these are the two types of waves that we observe. Now let's discuss some attributes of a wave. Alright, so let me just draw a wave over here. So let's suppose we have a wave. In the y-axis we have the displacement, in the x-axis we have the time. Alright, so I'm gonna draw a wave over here. So here's a wave. Now we have to discuss some attributes of the wave. Now the maximum distance from the mean position to the extreme position is called the amplitude. So we call it the amplitude. And if we have to write it, we'll say that the maximum distance, the maximum displacement from the mean position, is the amplitude. Now let's discuss about the time period. So time period is basically the time that it takes for a wave to complete one cycle. So let's suppose we start off from here. So the one cycle will complete all the way to this point. So one cycle will complete at this point. So the time that it takes for a wave to complete one cycle is called its time period. So for this example, the time period will be the time between these 2 points. So this one is the time period. By definition, we can say that the time it takes for a wave to complete one cycle. It takes for a wave to complete one cycle. This is called the time period. Now let's talk about the frequency. The next attribute of the wave is its frequency. So I'll write it here, frequency. So frequency is basically, by definition we can say the frequency are the number of cycles passing through a point in 1 second. I'll write it here. The number of cycles of a wave passing through a point in 1 second. Passing through a point in 1 second is the frequency. So now we will see the relationship between the frequency and the time period. So the relationship between the frequency and time period is that frequency is equal to 1 over the time period. So frequency is 1 over time period. We represent the time period. The unit of time period is obviously, because it's time, so its unit is second, and the unit for the frequency is hertz, H-E-R-T-Z, and we represent it with Hz. So this is the unit for the frequency. So after that we have to discuss about the wavelength. So wavelength is quite similar to time period, but for the wavelength we have distance in x-axis in place of time. So if we have a distance displacement graph, then we can say that the distance to complete one cycle is called the wavelength. So over here now we have distance instead of time. In the y-axis we have displacement. I'll write it here, displacement, so you won't get confused by d. So this is displacement and this is the distance. And we have a wave. So for this wave, let me tell you, we have two extreme position. One is the positive extreme and one is the negative extreme. So this is the positive extreme position, this is the positive extreme position, and this is the negative extreme position. So now this position is called crest. This is called crest, and this position is called trough. So wavelength is basically, it's the length between two consecutive crests or two consecutive troughs. So the distance between these two crests will be equal to a wavelength. This will be a wavelength. So I'll write it here, wavelength, and the unit of wavelength is meter. The distance between two consecutive crests or two consecutive troughs. Between two consecutive crests or two consecutive troughs. Is the wavelength. Okay, now after the wavelength we have to discuss about the speed of the wave. So the speed is simple. Speed is basically, it is the product of frequency and wavelength. So speed is basically the product of frequency and wavelength of a wave. Is the speed. So we represent speed by v. So v is equal to f lambda. It's a product of frequency and the wavelength, and the unit of speed is meters per second. So this is about the wavelength and speed of a wave. So after that we have to discuss the two types of wave. One is the transverse wave, one is the longitudinal wave. Let's discuss about their examples. So we have electromagnetic waves. So electromagnetic waves can be considered as the example of the transverse wave. Electromagnetic waves. So it is a type of transverse wave, and electromagnetic waves are all the light waves that are in our electromagnetic spectrum. So let me just write it here, that it is a transverse wave, and second one, all the electromagnetic waves travel at the same speed, that is the speed of light. All electromagnetic, I'll write EM for electromagnetic. All electromagnetic waves travel at the same speed, that is 3 times 10 to the power of 8 meters per second. And the electromagnetic waves whose frequency is more will have lesser wavelength, and the electromagnetic waves with lesser wavelength have more frequency, or the other way around. So the examples of electromagnetic waves are X-rays, gamma rays, visible light, ultraviolet rays, I'll write UV for ultraviolet rays. Then we'll have infrared waves and radio waves and microwaves. So these all types of waves have same speed in vacuum or in air, but they have different frequencies and wavelengths. And now let's discuss the next example for the longitudinal wave. So let's discuss the sound waves. So sound waves are basically, it's the type of longitudinal waves. It is the type of longitudinal waves. And as we have discussed earlier, that in the longitudinal waves, the direction of vibration is parallel to the direction of wave itself. So in sound waves, they are basically the longitudinal waves, and normally their speed in air or vacuum is around 340 meters per second. And they do not travel in vacuum, so we'll just say that their speed in air is 340 meters per second. And ultrasound is an application of the sound waves. So ultrasound is basically, it's a high frequency sound wave. So ultrasound waves have several applications. For example, measuring the depth of the ocean, measuring the depth of ocean, or examining the soft human tissues. So these are some of the uses that for which we use the ultrasound waves, and they are the longitudinal waves, and their speed is normally 340 meters per second, and they do not travel in vacuum. But the transverse waves or the electromagnetic waves, they do travel in the vacuum. So these are some of the basics from the topic of waves. Now we'll do an exam related practice question. Alright, so now we have an exam related question related to the waves. So it says waves can either be transverse or longitudinal. Describe the difference between the transverse and longitudinal waves. So as we have already discussed, in transverse waves, you'll write in transverse waves, the direction of vibration is perpendicular to the direction of the wave. The direction of vibration is perpendicular to the direction of wave. And for the longitudinal, we will write in longitudinal wave, In longitudinal waves, the direction of vibration is parallel to the direction of wave. To the direction of wave. So this is basically the difference between the transverse waves and the longitudinal waves. In transverse waves, the direction of waves, let's suppose it's up and down, but the direction of wave itself is towards right. The direction of vibration is like this, and the direction of wave is like this. But in the longitudinal waves, if the wave is going towards right, the direction of vibration will also be left right. So this is transverse, this is longitudinal. Now let's move on to part B. It says figure 1 shows a longitudinal wave. Add labels to figure 1 showing clearly what is meant by the terms compressions and rarefaction. So you can see these lines are basically showing the waves. So over here in this area, you can see these lines are close to each other. So this area belongs to the compressions, where the lines are close to each other. So we'll name them as compressions. And the areas where the lines are away from each other, like these ones, these areas belong to the rarefaction. So this is basically the rarefaction. Now let's see the next part. Okay, in part C it says figure 2 below shows a duck floating on the surface of a pond. As wave passes beneath the duck, they cause the duck to move. Add arrows to figure 2 showing the direction in which the duck will move. So let's suppose the wave is going in this direction or in this direction. What happens is the duck will move up and down, because if the wave goes right, this area will come under the duck, so the duck will move up. If the duck is over here and the wave goes more towards right, the duck will come down, so the duck will move up and down whether the wave goes left or right. So we'll mark these two arrows. The duck will move up and down. So this is how we can solve some exam related questions related to the topic of waves. Thank you.